How does null hypothesis impact statistical significance in A/B tests? Imagine you're trying to figure out if a new button color on your website actually boosts clicks or if the difference you see is just random. That's where the null hypothesis comes into play. It's the starting point in any A/B test, claiming there's no real difference between the control version and the new variation. It's like saying, any change we see is just by chance. When you run an A/B test, you collect data on how users interact with each version. The goal is to see if the difference in results is big enough to suggest a real effect. To do this, you calculate something called a p-value. The p-value tells you the chance of seeing your results, or even more extreme ones, if the null hypothesis is true. If this p-value is less than a set threshold, usually 0.5, you can reject the null hypothesis. That means you have enough evidence to say the difference is real and not just random noise. Rejecting the null hypothesis is a big deal. It means you can confidently say the new button color or feature actually impacts user behavior. This is what makes your test results trustworthy enough to make changes. But if the p-value is higher than the threshold, you can't reject the null hypothesis. That suggests the observed difference might just be due to chance, and you should be cautious about making changes based on that result. Understanding the null hypothesis also helps you avoid mistakes. If you reject the null when it's actually true, that's called a type I error or false positive. You might think your change works, but it doesn't. On the other hand, if you fail to reject the null when it's false, that's a type Roman II error or false negative. You might miss out on a change that actually improves things. In performance and optimization Saas tools, the null hypothesis helps automate this process. These tools calculate the p-value and tell you whether your results are statistically significant. This saves time and reduces guesswork, making sure you only implement changes backed by solid evidence. So, the null hypothesis sets the baseline assumption that nothing has changed. Statistical significance testing then checks if the data is strong enough to challenge that assumption. When it is, you can confidently move forward with your improvements. When it isn't, it's better to hold off and gather more data. This process keeps your decisions based on facts, not just hunches, helping you optimize your website or product with confidence.